Tutor, where school is made simple. Let's go.
In our continuing series on geometry, we're looking today at the Triangle Inequality Theorem. And again, we're trying to approach this using a very hands-on method that anybody can reproduce at home. So in this case, I have cable ties that I've purchased, different colors, just to kind of jazz things up a little bit, but all the same length, and then I've trimmed them down to use on this particular example. So one of the things I'm going to look at is the relationship between the lengths of each of these cable ties and their pieces and the triangle formed. So let's start by looking at the blue triangle. When I start to put the pieces together with the blue triangle, I notice a problem. The pieces don't meet. I can't form a triangle because they don't touch. And when I start to look at them, I say, okay, well, that's because they're equal. The sum of the two smaller pieces is equal to the bigger piece. It's an interesting observation, so let's take a look at another scenario. With the green one, now that I've looked at the size of the pieces, well, I see that some of the two pieces is smaller than the third one, so let's see. And again, I notice that I can't form a triangle. I get nowhere even close to it. So far I've noticed that when the sums of the sides are equal to the third side, it doesn't work. And when the sum of two sides is less than the third side, it also doesn't work. So let's take a look at another possibility. And that is when the sum of the two sides is greater than the third. So if we put these in order, I can see here that the bottom one is clearly the longest, and if I look at the relationship between the other two, I see that the sum of the other two sides is greater than the third. So now let's see if we can form a triangle here. Well, taking the pieces together, I see that yes, I can form a triangle. And this leads to what we call the Triangle Inequality Theorem, which is that the sum of two sides of a triangle must be greater than the third side. And we're going to confirm this by looking at it again in a digital form using dynamic geometry. But this is a hands-on approach that allows you to verify a basic concept in geometry.